FIS, how are you? Hey guys, can you hear me?
Yes.
Okay, so we'll give it a couple more minutes to see if there's any more people coming. Otherwise, we'll start at 5:35. Can you guys see the screen?
Yes, it is visual.
Okay.
And report.
Okay, so it's 5:35. We can start now. So, first problem we can start with is just an easy problem. So what we're doing here is we're merging two sorted lists. So you're given the heads of two sorted linked lists, list one and list two. And what we want to do here is we want to merge both the lists into one sorted list. And the list should be made by slicing together the nodes of the first two lists. So as you can see in this picture over here, you've got list one and then list two. What you want to do is merge these nodes over here, and the resultant list should have all these nodes in order and sequence like this. And then at the end, you need to return the head of the merged linked list. So that would be a pointer to one. And so these are some example inputs. You have list one, 1, 2, 4, and then 1, 3, 4, and then what should be outputted should be 1, 1, 2, 3, 4, 4. And then if an edge case is if you're given two
Can you just
NP,
share the link for the
Since why CNN ये कैसे
pardon me?
link to the problem, the one which we are solving?
Yes, I'll put it in the chat. So did all of you have a chance to read the problem? Okay, so who has an idea on how to attack this problem? Just like just give like a slight overview and then we can go into coding it.
Okay, pacing.
We can just merge using the mod sort.
Here. It where?
No, that's the cursor of anyone
Someone
else.
who is pairs.
Do you want to share your screen and show?
No, no.
Okay, you don't.
I have not coded, but I can just explain part of my logic.
Final report on
Okay.
this. Okay, there are no source code.
Like we will be just having 2 pointers on the head of each of the list and then incrementing the pointer depending on which head value is the smaller one. The one which is smaller will be incrementing and adding it to the third list. Like we'll need one more to store the values.
No, that's.
Okay, do you wanna code that out in Python?
Yeah, but I'm not very comfortable with Python, so I may take time.
Yeah, that's fine. You can just, I can help you once you share your screen.
Oh yeah,
Okay.
2 minutes. सर और देखने पड़ेगा चाहिए.
Yeah. List 1 and list 2 are head of the two linked lists. So I need to
Okay.
put 2 pointers on this.
चलो I'll leave.
Okay. Yeah.
So can I just directly add, like suppose P1 and P2 are my 2 pointers?
Yep.
Submit this.
So am I supposed to add directly list 1? And how am I supposed to access the values? Like,
So this is a linked list.
One
So
solution for
yeah, I'm not sure how do we access linked list in Python.
so the first value would be the head. So in
Yeah.
order to iterate through the list, you would use the dot next as an attribute. So um they say that list 1 and list 2 are the heads of the two given linked lists. So if you want to access the next value, you would need list 1 dot next.
everyone.
And so how you could either
nice.
do a
I
while
have this
loop
table.
or you can do recursion to go through the linked list.
Okay.
It automatically suggested grade and mission.
I'm not sure with the syntax. I'm okay with the logic, but I'm not sure with the syntax.
Yeah, syntax in Python, you don't need parentheses. So
But what will be the while condition? Like till the time I reached end of one of the list, right?
yeah, so you don't want the end to be null.
Yeah. I don't want to any of means either of both. The one I'm not sure about the link.
As you can say, it's flex.
So when you're looping through the list, you don't want the end node to be null. So you need like while P1 is not equal to, so exclamation equal to null NULL.
I'm sorry, I missed you. P1
Doesn't equal to null.
equal to null. Okay.
You're solving with some.
Yeah.
Okay.
Is that has to be
So try none instead of null
And then you are
in capital N.
okay, it works.
why you are not.
But I'm not sure if P1 is long or P2 is long. I need to check the length of each of them first, right?
Yes, you'll need to check the values, compare the values.
Yeah, but before this, like, okay, I'll
There will
get
be a time where I will only do it. Only do it.
some stuck.
Now probably is not. Where you going? Remember him. No, where you going? I'm going to my room. I will freshen up. क्या कर रहे हो? अभी क्या करने वाले?
So what you want to do is, once you compare P1 and P2, you return you return the head of P1. So if P1 is larger than P2, then you return the head of
Refresh through
P1.
the linked list.
Please share your screen. I guess that will be comfortable for me.
Okay, let's see. Okay, so we'll start with a simple case. So if you're, so let's go through an edge case first. If list one is not given, so if it's an empty list, or if list two is an empty list, then you return list one or list two. So why I wrote this is that, so if you look at this example over here, you're given two empty linked lists. And once you're fed that into the function, you need to return an empty list as the result. So this is what achieves that. Now, if we're looking at the first node that we're looking at is the head. So we will first compare the values. And so when L1, the value of list one, so say the first node over here, if that is less than L2.val, then we would then assign L1.next as a recursive function. So what this is doing is it's iterating to the next node over here, so 2, and then it will keep on comparing until it reaches the end of list 1. And then at the end, you're returning node to, let's see. So you're returning the head to list 1. But if this condition does not work, then you would need to assign list2.next as the recursive function. So what this does, it looks at the values in list 2, and then it iterates all through the end of list 2, and then returns the head pointer to list 2. Let's see. Yep, so that was a problem over there. So that's another thing to keep in mind is to when you're checking edge cases, you that could present a problem in your output. So what happened here is that it wasn't taking into account the um, if list two happened to be empty an empty list. So that's why we didn't get all the values down here. So now it checks the edge case where you get the empty list, and then this portion over here, it checks all the values of list one, and then this one checks all the values of list two, and then at the end it gives you the pointer to the head node. And this is only one solution because this is a recursive function. It can also be done in a iterative manner, like using a while loop. So then you wouldn't have to waste memory on the stack. Are there any questions? Okay, so is everyone done with doing this problem?
Yes, it is done.
Okay, and you're getting the intended results, right?
Yes.
Okay, well, we'll move on to the second problem. Okay, so given the head of a linked list, determine if the linked list has a cycle in it. So there's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, pose is used to denote the index of the node that tail's next pointer is connected to. Note that pose is not passed as a parameter. Return true if there's a cycle in the linked list, otherwise return false. So basically what they're asking is you're given a linked list of any size over here. And what you want to do is see if any of the values link to any existing nodes within the linked list. So for example, if you look at -4 over here, the next node in the sequence would be 2. So there is a cycle over here. So you need to return true if there's a cycle. Otherwise, if there was no arrow here, so if the next node was a null, then you would return false. It could also be like that, if you had like if next node over here would could have been 3 too. So you what you're basically looking at is if the next node is linked to any of the nodes that you've seen previously. So if you're looking at the examples here, so this one outputs true because as you see over here, -4 is connected to 2, which shows that there's a cycle. So you'd have to check not just the node values, but the actual node itself. So you could attack this in many different ways. I think one popular way is to set a hash map or a set. So, and then you can keep track of the values in that and check if once you're iterating through the linked list, check if a node is within that set. If it is, then you return true, or if it's not, you return false. So does anybody want to try coding it out? Okay, so one possible solution for this problem would be would define a function called has cycle. Okay, so the first thing we want to do is we want to define a data structure to save all visited nodes. So in this case, so a common data structure that people come up with would be a list, but then uh, you have to keep in mind that lists, whenever you append an item to a list, there's no way of checking whether that item has occurred or not. So you could have duplicates of nodes within a list. So instead of that, do you know any other data structure would be apt in this use case? So one possible data structure here, because you don't want any duplicate nodes saved in it, would be a set, because all items within a set are unique. So in Python, the way you initialize a set would just be set and in parentheses. And now you'll have to iterate through um, the linked list that you're given. So we're first given the head, and so we'll be iterating through by looking at the next value. So if you look over here, you can see that node is defined with an attribute next. So let's say head was 3. So the next value over here would equal to 2. So that way we can iterate through the linked list. And our end condition would be none. So we don't want so this while loop will stop once we reach the end of the linked list. That's where the next node would be none. So we're looking whether the current node isn't visited. If it is, we know that there's a cycle within the linked list, so we would return true. Otherwise, we would add the node to our set. And then at the end, we make sure to update the head node. So that it doesn't stop at this node, so that it iterates through until it reaches the end. And if that doesn't work, if no cycles were identified, then you would make sure to return false at the end. Does anybody have any questions about the logic? there's no more questions about either of the problems, I guess we can end the meeting here, and then we'll do 2 other problems next Friday at the same time at 5:30.